Hello and welcome to the first installment of your vocabulary for geometry. Hopefully in your notebook you have a page set up somewhat like this for your vocab. Remember, you need to write down everything. You can always go back, re-listen, pause, rewind. You're going to want to stop. I'm going to go pretty fast. You might not have time to keep up, but please go back and re-listen. That's the glory of this setup, is you can go at your own pace and do what you need to do to understand these words and get them written down. I'm going to start with a math joke. The math joke goes like this. How do you make 7 even? How do you make 7 even? Well, you take away the S and it becomes even. Kind of clever, I thought. Okay, here we go. The first word that you need to write down is point. Point is an undefined word. You're going to see this here with the first 3 words that I'm going to give to you. It is considered an undefined word, which is kind of weird because I'm giving you an actual definition. But it's not something that has really a definition, because look at the definition. The definition is just that it is a location in space. Then I can tell you about it, that it's represented by a dot, an uppercase letter. It has no dimension, so I can describe it, but it's not actually anything, so we consider it an undefined term. Very abstract idea here in geometry, but this is considered one of the 3 undefined terms in geometry. This is what you would do to represent it. You'd put a dot and an uppercase letter, okay? You might see it written later as just M, or you could write it as point M. But if you see an uppercase single letter, you're making the assumption that that is a point, okay? A lot of times in class especially, we'll write out the word point M so that you understand what we're talking about. But if you see a letter uppercase that's all by itself, it is talking about a point. Okay, next word. This is where if you need more time with points, stop, write down more, and then hit pause, hit play, and then we'll go on to the next one. Line. Line is our second undefined term, so we can't really define it. We can describe it. Here's a description of it. It has 1 dimension. Notice that the point above had no dimension. This one has 1 dimension. That's interesting. They're getting into more dimensions. It's represented by a line with 2 arrows and 2 uppercase letters that extends without end. So the 2 uppercase letters, you're making the idea that there are points all along this line. So there's a point A and a point B. That's why they're uppercase letters. These are the 2 ways that it could be represented. So this is the image. This is a figure that you can use to represent line AB. Notice there's arrows on either end of the line up here. It lets us know that it is a line. It goes on forever in 2 directions. And there's AB. So any 2 points on that line can be used to represent this line. If we want to write it out, sometimes you don't have something on your computer to make this fancy little line above it, then we just write line AB. And you'll see that in a lot of the things the teachers will make for you. We'll just write it out, line AB. Okay, third undefined word is plane. So point, line, and plane are your 3 undefined words, all right? It's a flat surface made up of points. We can describe it once again, represented by a slanted 4-sided figure and 4 uppercase letters. This one has 2 dimensions. So point has no dimension, line has 1 dimension, plane goes out in 2 dimensions. It goes like this one will go up and down and side to side. It extends without end, just like a line does. It extends without end. It goes on forever and ever and ever. The way we represent it is with a parallelogram. Not sure why. We don't use like a rectangle, but we don't. Use a parallelogram like this. And this represents that it goes on and on and on in all these directions. This way, this way, this way, this way. So there's 2 dimensions there that it goes on forever. This would be a shorthand way of writing it, would be drawing the parallelogram, QRST. It needs all 4 of them to represent it. Or you say plane QRST. Okay, if you need to go back to this page, I may go into the next page, hit pause, rewind, do whatever you need to do. Next word, collinear. Collinear are points that lie on the same line. points that lie on the same line. So point A, B, and C here are called collinear because they all are lying on the same line. Now watch this. If I take point B, ooh, I can't grab point B. Come on, let me grab point B. Ah, there we go. Just one sec. Dang it. Okay, I'm gonna have to move the line just a hair. If I move point A up there, those are no longer collinear, okay? So we still have 3 points, but they all have to be on this line. So if I take this point and I move it down here, now point A is collinear because it's on the same line as A, B, and C. Not sure that was worth the time to show you, but hopefully maybe helps you understand it a little bit. Okay, next word, coplanar, very similar to collinear. Notice they both start with co. This has the word line in it. This has the word plane in it. So these are points that lie on the same plane. For example, x, y, and z here all are on this plane. You can also call a plane by a lowercase letter. So you could have something like S. And see this lowercase s, and it's usually up in a corner? So you could call this plane XYZ. These points, X, Y, and Z, are all in the plane, so we could call it plane XYZ. Although it is nice to have 4 of them to call it that. So what a lot of times we'll do is we'll use a lowercase letter, we'll put it up in the corner, and that's another way to name a plane. We're going to go over this in class, so don't freak out if you're like, I'm not understanding this. But a lowercase letter up in the corner of a plane can also be a way to represent a plane. Okay? Okay, hit pause if you need to. Line segment. So remember on the last slide we had line. This is line segment, and the word segment is really important. This is a line, but it consists of 2 endpoints and all of the points in between them. So notice there's no arrow here, there's no arrow here. There's actually a point in and a point M, and this line does not extend beyond these 2 points. Okay, and that's really important. And then every single point that's between them is part of this line segment. So there's an infinite number, a bazillion, trillion, those are my made up number words, points that are in between M and N. Okay, and yeah, all those points are part of the line segment. Once again, this is how you'd write it. Notice there's no arrows on the end of MN. Next word, ray. A line with one endpoint and one side that extends without end. So here we've got an endpoint at K. It goes on in this direction towards L, and it's going to go forever, ever, ever. We write it as KL, ray KL. Start with the point and go to the line that's going on forever, the way that's going on forever. So if you said ray LK, I would think L would be the endpoint and it would be going towards K. So start with where the endpoint is when you're referring to a ray. Okay, going to the next page. So hit pause if you need to go back to this page. I know I'm going fast, so hit pause when you need to. Okay, intersection. A set of points that have two or more geometric figures have in common. Usually we think of this with lines, but you can have planes that intersect. You can have a line and a plane that intersects. You could think of it like roads, right? If this is a road and this is a road, where do they intersect? It's the same word. We would say here that line AB and line CD intersect at point E. There's usually a point. There's always a, well, no. Yes, if they intersect, there's always a point where they're going to intersect. Point of intersection, and we'll usually give that point a name too, like letter E. Okay. Congruent. Two or more geometric figures that have the same size and the same shape. This is the symbol for congruent. So if I have a line MN here, line segment, excuse me, and a line segment WV here, those two line segments are congruent, then you put this cool little symbol in between. One of my favorite things about geometry is using this funky little equal sign. Similar to equal, notice that it has the equal sign in it, but when it has a squiggly on top, it's not just an equal size, it's also got to be an equal shape. So if this was 2 centimeters long, this one would be 2 centimeters long, we'd say they're congruent. I'm using that little symbol a lot, so be ready for it. Last one on this slide is between. When 3 points are collinear, 1 point is between the other two. Okay, so here we've got A, B, and C, and we say B is between A and C. I'm going to try and lock this because I think if I lock it, then I can grab B. Yes. Okay, so B is right here, and it's between A and C. If it's over here, it's still between A and C. If it's over here, it's still between A and C. So any of these places, it's between A and C. If I put it over here, now C would be between B and A. So when you have 3 points, one's going to be between them if they're collinear points. There's something really important to remember about between, though, okay? And I'll talk about that on the next slide. Hit pause if you need to. Last slide. Here we go. Doing great. So I said there was something important about between. A lot of times people get between and midpoint mixed up. Between just means it's between, where the midpoint means it's a point and it's between C and E. D is between C and E. But this point divides a line segment into 2 congruent segments. So if I take this, and I'll lock this really quick. If I take D and I move it over here, come on. Oh, come on. I must have locked D too. Anyway, if I move D and I put it over here, it would no longer be the midpoint. It would still be between, not necessarily the midpoint. So D is the midpoint of CE, and it makes these 2 line segments congruent. So let's say from C to E is 6 centimeters. If D is the midpoint, you really have to watch for that word, then we know that this would be 3 and this would be 3. Okay, and midpoint's going to cut a line segment in half. Okay, notice this is a line. It has arrows on both ends, but I am just talking about the line segment, CE here, because I didn't put arrows at the end. Okay, hit pause if you need to. Hopefully that's clear. We'll go over it in class some more. Segment bisector. Oh, this is a big one. Oh, and I think this is the end. Segment bisector, a point, ray, line segment, or plane that intersects a segment at its midpoint. So the best way to go over this is with an example, okay? So if I have line segment PT here, and I have GH as a ray, and that GH is going to intersect PT at point J, it is called a segment bisector if it happens to hit point J is the midpoint of PT. So if point J cuts PT in half, then it is called a segment bisector. And you can have a point that's a segment bisector, a ray, a line segment, or a plane. So anything here that comes and cuts PT in half is considered a segment bisector. The really important part here is the word bisect. So right here is the word bisect. And what I might do if I were you, this is going to get really ugly because it's hard to write in this, but it'll give you the idea, is I would like underline this little part bisect right here, okay? And I would write something about that this word means cuts in half, okay? So you can have a segment bisector, you can have an angle bisector, you can just have that point X bisects line segment PT. So whenever you see this word bisect, you need to think half. Notice that we're putting it right under the word midpoint because midpoint cuts them in half. So a bisector will always create a midpoint on a line. Okay, so if you see midpoint, you got to think half. Bisect, you got to think half. Equal parts, equal sizes. Okay. Okay, I think that's it. If you've got questions, ask them in class. Sometimes something in here, you know, might not be quite clear and everything, but it looks like we're good. We're right at about 14.5 minutes. So good luck and study for that vocab quiz. Bye.